Hello, welcome back. In this video, we will be doing one more challenge on Microcorruption. It's going to be Santa Cruz. This challenge is about bypassing the length check of any kind of input. So basically, this Santa Cruz challenge is having a pretty interesting vulnerability inside of its code, and the thing is that we need or we have to exploit that vulnerability inside of the code. So before I start solving the challenge, the same advice always to solve the challenge on your own before you watch me solve it for you. And don't just try to mimic what I do. Try to understand the approaches I'm using to solve the challenge. What else? Don't forget to follow me on Twitter. Don't forget to join the Discord server and just subscribe, I think. Yes, so let's not waste too much time and start the challenge. So what do we have? So overview. So a firmware update further rejects password which are too long. So this lock is attached to the Lock ID Pro Hardware Security Module 1. So okay, so let's try to continue and see what this program is doing. So username is gonna be itembyte and password is gonna be itembyte 123. So if we try to use that, we see that we have the password is not correct and he's printing for us the username and the password. Okay, so if we try to reverse engineer this code statically, what are we gonna be having? So basically, if we try to search for the main, so this is the main, which is having just some usual stuff by initializing the stack pointer and then just calling the login function. What else do we have? So we have this, so this is the login function. So this is the usual stuff we use basically when we start to initialize any kind of stack frame. So this is basically a stack frame. Now, here's the thing. We are moving the stack pointer to the register 4. Then we are adding 4 to the register 4. And then we are adding this negative value to the stack pointer. Now, okay, so basically we're going to be using the register 4 as the base pointer that we're going to be using to point to different places on the stack. So basically, so the first thing we are going to be doing, we are going to be just moving 0 to this offset from the stack, just from the register 4, I'm sorry. So if we have register 4 minus 0x6 is going to be 0x00. This is going to be minus 0x8 or just 19, sorry, is going to be 0x8. And register 4 minus 0x18 is gonna be 0x10. Now, those are just some initializations to some kind of values that are hard-coded inside of the memory. And we're gonna be seeing what those values are exactly. So the same usual messages. So authentication requires username and password, and both are 8 and 16 characters. So just this is just printing the messages, and then we are starting to read the input. So the first input that we're gonna be reading is the username. So this is reading the username. The username. So this is the size of the username, which is 99 bytes, and this is the destination address. Now once we finish reading the username, we also gonna be printing that username. So we print the username and then we copy. So we copy the username to the stack. So basically this is copying the username to the stack. So this is the source address and this is going to be the destination address. Once we finish that, we enter the password and we start reading also the password. So this is reading the password And as you can see, we are reading 0x63, which is also size of the password is gonna be 99 bytes of data. And this is the destination address also. What else? So we're gonna be printing the password also. So this is printing the password. And as you can see, we are using the same temporary address, which is 0x2404. Now once we do that, we start also copying the password to the stack. So since this is basically the address of the password that we have read, and this is basically the destination, which is gonna be this address, which is register for minus this negative value. Yes. So once we finish that, we basically start. So we move the register 11 into the register 15. So basically, the register 11 is having the address of the password, and then we move register 4 into. So basically, register 15 is gonna be equals to register 11, which is address of the password. And then we move register 14 to we move register 4, I'm sorry, to register 14. And then we add, so register 14 equals to register 14 minus that value. um I don't have to convert it actually, just this negative value. Then we increment the register 14, so register 14 plus plus, and then we test if the register 14 or the character at that offset. So if register 14 is equal to 0, is that equal to 0? So if it's not equal to 0, then we loop back again. So this is basically a loop that's going to be trying to travel the password or iterating through the password um, until it hits the end of the password. Yes. So and then we move what's in the register 11 into the what's in the register 14. I'm sorry, into the register 11, and then we subtract basically. So we subtract basically the beginning of the password, which is already in the register 11, or basically we subtract basically the size of the password minus the beginning. So basically this is gonna be calculating the size of the password. So register 11 equals to register 11 minus register 15, which is the beginning of the string. So basically this is gonna be calculating. So this is basically the size of the password. So and then we check. So we move what's in the offset of minus 0x18, which we already initialized, which is this one. We move it. Um, we move it into a register 15, which is now we are basically register for minus 0x18, which is 0x10, which is 16. We basically move it into the register 15, and then we sign extend it. Then we compare what's in the register 15 with the register 11. So basically this block is checking if the length of the password is 16. So check if the size of the password equals to 16. So we can just do like that. Check if the size of the password is equal to 16. So if there is some carry, which means that the register 15 is bigger than or is lower than the register 11, then we basically jump. So if there is a carry, basically we just stop executing the program. Otherwise, we jump to this other check, which is this one. So we move what's in the register for minus 0x19, which is 8. So basically resistor 15 is going to be equal to the resistor 4 minus 0x19, which is equals to 0x8, and then we sign extended and then we compare. So we check if this size of the password, so basically it's not equal to 16. This is inferior or equal. Since it is basically a jump if not carry. So we check if this size of the password is superior or equal to the 8, because we are using now jump if there is a carry. Yes. So now we move this address to the register 15 and then we print the wrong message if basically there is no carry. Otherwise, we move 0 to 0x2c to this offset in the stack, and then we are basically trying to initialize some kind of interrupt. So we move that address, and this is basically the stuff that we have to do to initialize the interrupt. So basically, we're gonna be passing down the username and the password and the interrupt number that we are gonna be using with the hardware security module 1. Once we finish that, we just clean up the stack since we did a call. So we clean up the stack, and then once we do that, we check if the value at the offset of register 4 minus 0x2c, which we have passed down, is equal. So if it is equal to 0, then we just print that the password is not correct. Otherwise, we just unlock the door and give give them the access granted. So basically, this address just to is the address of the result, basically, of the hardware security module 1 function, or just this big function, which is test username and password valid, which we do not know basically because it is a black box. We do not have the code, and we do not have the code inside of that interrupt. We do not know exactly how the checks are happening and all of that. So basically, this is what the program is doing. So how can we exploit such a thing? So the thing is, if we try now to do some dynamic analysis and try to see how the stack layout is designed exactly to know what the password is, where the username is, and where those hard-coded values are, and where the return is, and try to return to the unlocked door and exploit the code. So if we try to, for example, set a breakpoint um, at this str copy. So before copying the password and after copying the password to see how the username and the password are being copied into the memory and try to see what's exactly happening. So if we reset, so if we put a breakpoint in here, so this is the first breakpoint, and if we put another breakpoint there, and if we continue, so the username is going to be ironbyte, the password is going to be ironbyte123. So this is the first breakpoint. So this is basically before copying the password inside of the memory. So this is the username. So this is the offset where we start copying the username exactly inside of the memory or inside of the address space of the stack. This is the return address. Obviously, if we can check that. So basically, if we just search for 44 for A or 40, I'm sorry. So basically, yes, this is just the step program execution. Um, yes, which is the next address after calling to log in. Those are the 10 that is hard coded, and this is the 08. And there is also another value which is the 0 that he is also loading. So we can check those values just by trying to set a breakpoint inside of these, inside one of them, just to see the value inside of the register for and then calculate it manually. So if we reset, if we continue, we see that this is the register for which is having 43cc. If we try to use Python to calculate the offset manually, so this is 0x uh, minus 0x 6, so which is 0x 43 C6, yeah, C6. So this is so let's try to continue this step to see that value C6 43 C6. So this is basically the value should be in here. So basically 0 1 4 5 and 6. It should be this one. So 0 1 2 3 4 5 6. No, it should be this one. This is basically the resistor for minus 0x6 and so on. So basically now if we try to continue again, item byte 1 2 3, and we continue again, we see that this is basically the resistor for minus 0x18 and this is minus 0x19, and the 6 should be this one. Yes, so this is registered for minus 0x. So those are the three hard-coded values, which are those three ones. Now here's the thing. If we try to use the username to change now the length that the program can support, because if we try to override this 10 and make it, for example, FF, which is 256, then we can read 256 well, just password length. For example, we can read a password with a length of 256, and then we can basically overwrite that value basically. And we can, for example, so this is the minimum boundary for the length password, and this is basically the maximum length password that the program can support. So if we change them just using the username by overriding those values, and then we keep overriding all of that until we try to, for example, override also the return address and make it go to the unlocked door function. And then using the password, for example, we can read all those data and then just make sure that we can just pass down this little zero, because when we are going to be using the username, we're going to be overriding this value and this value, and we're going to be overriding this zero into some random data and then to get to the return address. I'm going to be using that technique basically because we are using the str copy. And if I'm going to be using the str copy, I need to do it this way. Why, guys? Simply because if I try to, for example, try to just override this value and this value using the username, and then, for example, when I'm gonna be just saying that I'm gonna be using the password to override the return address, I can't. Why? Simply because when I'm gonna be sending some random data and then E0, the str copy will stop copying data because it hits E0 and the return address won't change. So to make sure that I'm gonna be changing the return address, I'm gonna be overriding everything and then override the return address, and then I'm gonna be coming back to this zero and change it using the password. So this is basically the payload. So let's try with the first step, which is overriding everything. So using the username. So I'm gonna be sending 14 bytes of data plus 16, 17, and then I'm gonna be hitting the 8 and the 10. So basically, we're gonna be sending 41 by 17 plus these. Let's say I'm gonna be setting the boundary from the 08 to 0 to FF, and then um, I'm gonna be completing the other ones, which are those ones. So this is a 1, so let's just calculate those, which are 2 4 8 10, and this is 11 um, 12 13 14 15 16 17, and this is 18. So basically I'm gonna be sending 41 um, 18 plus, let's complete them, 19 20 21 22 23, which are 23 And then this is gonna be the return address, which is the return address I'm gonna be returning to the unlock door function, which is 44 for A, which is, if we use the little Indian, we just flip the bytes. We see we have this payload. So let's try to use this payload and check if it is going to be loaded rightly inside of the memory or not. So we don't need that breakpoint anymore. C, we check the X encoded. Um, and as we can see, the return address should be good. Yeah, should be good. We have successfully loaded that username. So this is the username. We have overridden these two values. Now the check of the password should be bypassed. We can now send infinite. Well, infinite is a huge word. 256 basically bytes of password or bytes of data for the password. And we have successfully overridden the return address. Now what needs to be now added is basically using the password. I'm gonna get back that 0 back. So I'm gonna be sending. So this is the beginning of the password. So I'm gonna be sending um 1 2. So again, basically, I'm gonna be sending 17 17 random data, and then I'm gonna be sending our 0 just to make sure that the canary is not having any problem with us. So yeah, so just 41 by 17 plus 0. We try to do that. Continue. We hit the breakpoint, and what do we have? So this is before the str copy. Yes, and this is after the str copy. So this is our 0. Now if you try to continue, the lock should be unlocked. Yes, cool. If you try to solve that on this server, who knows? The canaries might be changing or something. Who knows? If you try to send that one and send that one, yes, we have solved it. So basically, this is an interesting challenge. Basically, this is what happens when developers do not give too much attention to the details when reading inputs. Yes, I hope you have learned something new. Yes, that's it. Don't forget to follow me on Twitter again. Don't forget to hit the sub button for more videos. We're gonna be completing microcorruption soon. We still have some kind of challenges to see. Who knows what we might have into those challenges? Yes. That's it. Have a nice day. Bye.